number one, okay, number one here, this is going to be the learning target number 2. I'll try to put the learning targets up here also to help you guys. Okay, you have to be able to identify what the inequality would be from that number line. So here, I know I'm going to start with x. I know I'm going to put 12 on there, right, everybody? Because that's going to, obviously, x is my variable. Now, you could use any variable, whatever variable you want if this was the question on the test, but for this, what we're doing today, I made them all x's just to simplify it. First thing I identify is that it is a what type of dot? Close. So I know it's going to have that on there, right? Yeah. Now, let's say that you didn't know. You thought it was either this or this. So you thought maybe it's one of these, right? You guys all agree with that? Yeah. And you're really having a hard time remembering which is less than, which is greater than. Now, this one's a less than. Remember, it kind of looks like an L, right? It's a good way to remember it. But just pick a number. What's a number in that solution that I could use? Anybody? Cam? 8 would be perfect. 8 would be somewhere over here. If I took 8 and plugged it in there, which one of these would be true? Would it be trying to eat 12 or would it be trying to eat 8? Obviously, this would be the answer. 8x would be less than or equal to 12.
Please call the office, Mrs. Jones.
Okay, this right here, guys, is going to be learning target number 1, solving one-step equations. The first step is to obviously draw your line, right, everybody? Yes. Then we ask what is happening to the variable. Okay, what is happening to the variable? It's being subtracted by 8, or you could say 8 is being taken from it. Put writing, please. Okay, so I need to undo that by adding 8 to both sides. So then I learned that x is going to equal 10, right? Am I done? No. Remember that last step is just to quickly take it and plug it in. And make sure that when you plug in, 10 in for x, make sure it gives you what it's supposed to, does it? Okay, so x equals 10 would be your answer there. So again, this is learning target number 1. Also, guys, hey. This is also learning target number 1, solving one-step equations. Obviously, I'd be wanting to check your work. Now, the biggest mistake here, Eunice, you with me, man? All right. Okay. The biggest mistake here that we've got to be real careful of is you guys, a lot of you, we're not doing it as much, but I still got some people thinking that they got to multiply by 3/4 because I've taught them that all fractions are division problems. But it's not about what's happening to 3/4. It's about what's happening to what, Monty? The variable, yes, the x, exactly. So what is happening to the variable in this case? Asia?
It is being multiplied.
It's being multiplied. So how do I undo that? Eve? Divide by 3/4. Now, I like to write it up here, right, guys? Yeah. Because I always like to show the algorithm right here. Do you have to show this next step, the algorithm? Yeah. Showing it being the reciprocal and all that? Yes. You would have to show this work. And if you don't, it would be wrong tomorrow. We know the dividend is going to stay the same. The division is going to become multiplication. And the reciprocal of 3/4 is 4/3. Now at this step right here, can I cross simplify? Yeah. I can. It doesn't matter whether you want to or not. Either you simplify at the end or you can cross simplify. I see that 3 and 3 are there. Those both have a factor of 3. So I'm going to divide out that 3 and I'm going to get 4. So I know that my x equals 4. Am I done? What's the last step that I have to do? Plug it in. So this one you may have to rewrite. You might not be able to just do it in your head. 3/4 times 4/1. Now again, you can cross simplify here if you wanted. I won't this time. It doesn't matter. Regardless, I get 12/4. That equals 3. Is that what it was supposed to equal? Is there any other answer for x that I could put in here on this one? Not at all. There's nothing else that I could put in there, okay? So that would be x equals 4. If I'm writing an inequality here, I think this is learning target 3, I'm pretty sure. I'm pretty sure it is. No, it is. It's writing an inequality from a real-life sentence. Okay, so this is learning target number 3. So what's the real key word here? Or 2 words? Yeah, Lexi.
At most.
At most. Now remember, when you have those words like at most, at least, maximum, minimum, what kind of inequalities were all 4 of those? Unisa? The or equal to ones? Is that what you're saying? Yep. They would have the or equal to. So the real deal here is you start with x, you start with 8, and then just ask yourself, if a number x is at most 8, can it be exactly 8? Yes. Sure it can. Okay, so right away, that's where I start. Now we'll go back to the method I kind of gave you just a minute ago when I said, if you just wrote them both, like let's say I wrote this one here and this one here. Now I could just start thinking, okay, which one would make sense? Can I have 8 or less, or can I have 8 or more? That's really the whole idea you can have here. So what is it? 8 or less. So which one of these two inequalities would be the correct one? Yeah. This one here, right? Absolutely. That would be it. This would be at least 28. Or I'm sorry, at least 8. So we know that this is saying if x can be at most 8, that means it could be 8, it could be 7, it could be 6, 5, 4. All of those numbers would make that statement true. Everybody agree? Okay, good. All right. Okay, this same question is going to be on the test. The only difference is, I'll just tell you this right now. On the test, what I'm going to do is I'm going to give you something like this. What was it? I'm going to give you a line like y equals 3x minus 4, something like that. And then I'm basically going to give you several points. Like that. And I'm going to say, I don't even know if these work or not, but that's irrelevant. I'm just going to give you these, and I'm going to say, I want to know, I'll be specific and make sure I tell you right. Yeah, I'm going to ask you which of these do not represent ordered pairs. So how you do it is you take your x's and you just plug them in and see what y you get out. If it's not that y, then you did something wrong. But we'll go back to this one now. Okay? So basically here, this is a line. You guys know that, right? We talked about it yesterday. You don't understand why it's a line or how it's a line. You don't know anything about why it's a line. You just have to understand that when you see y equals and then something happening to x, you know it's a line. It's forming a line. That's all you need to know. That's all you need to care about. Do you guys understand?
Yes.
And on that line, there are many coordinates, points. There's an infinite amount of points. We need to know if this one specifically is on that line. I see people writing and stuff. Stop. Listen. Okay? So all you can do is you can control your independent variable, which is your x. And what you're going to do is you're going to plug that in. Right, everybody? This is the work I would require. We're going to take 3. We're going to plug it in there. Like that. Right, everybody? And then we're just going to ask ourselves what y we would get out. That's the whole point. Now, you got to follow PEMDAS and all that's still the same. But we end up getting 9, and then 9 minus 4 would give us a y of what? So that means my x is 3. Or if my x is 3, my independent, my cause, as you guys learned it in science, if my x is 3, then in that specific line, my y has to be 5. Therefore, is that point on the line? Absolutely yes. Does that make it more? Are we feeling better about that? Okay, good. All right, let's go to the next question. Okay, this is going to be learning target number 4. So this is just solving one-step inequalities. It's the same target as learning target 1. Only difference is it's not an equation. There's no equal sign. It's an inequality symbol. So you still draw your line. You still ask yourself what is happening to the variable. You still undo whatever's happening to the variable using, Unisa, using inverse operation. So then we're going to divide 3 to both sides. Divide 3 to both. Now I'm going to learn that x is going to be greater than 4. And there's your answer. Now if we were graphing that, it would look like this. You didn't have to, but I'll just show you now. We would put 0, 4, and negative 4. Would this be an open or a closed dot? And then where would our solutions be if we're talking about solutions greater than 4? They would be to the right. Okay, everybody got that? Yeah. All right. Okay, so you have to prove these. That's the whole key here. Now on the test tomorrow, there's going to be 5 of these. They'll be just like we had on the formative. We had the instructions, and then there was 5 that I went through and I wrote like number 9, number 10. Remember that, guys? Yeah. So that'll be the same way on the summative. So it's great if you thought the answer was true or you thought it was false, but you have to prove to me why you said it was true or false. If you just have true or false, I want everybody to hear me. If you just circle true, you say, yep, that's my answer, it's wrong. You guys understand me? Okay, just making sure. There are 2 ways to prove. 2 ways. The first way is probably the way I think would be the easiest when you simply just solve the equation. Now when you solve that, some of you might have tried to do 1 divided by 4 and got 0.25. I don't know if you did that or not, but hopefully you realize that, well, if I'm doing 1 divided by 4, isn't that just the fraction 1/4? Which isn't that what that is? Yes, it is. Okay, now that's the first way you could have done it. The other way you could do it, and maybe, it's a fine way, but I think the solving is pretty easy. You just go ahead and take this. You're just going to plug it in. So you're going to take 4. You're going to go ahead and multiply that by 1/4. If it gives you anything other than 1, then you know it's false, right? So obviously you should know already, what are those numbers of each other? Reciprocals of each other. We know that all reciprocals have a product of what? 1. There you go. So we know if we did that, we'd get 16 over 16, which indeed does equal 1. Everybody go with that?
Yeah.
All righty. Let's go on. This, again, is learning target number 1. A little bit trickier only because now we're talking about fractions. Again, what is happening to the variable? It's being multiplied by 2/3, so we need to undo that by dividing by 2/3. Dividing by 2/3. Do you need to show your algorithm for division of fractions? Yes, 2/9. Division becomes? And the reciprocal of 2/3 is? 3 over 2. Now, you could cross simplify here if you wanted to. I'll do that. I know that 3 and 9 both have a factor of 3, so I'm going to divide out that 3. Then 2 and 2, those both can become 1 because they have a factor of 2. That's going to be 1/3. So we learned that x equals 1/3. Am I done? Now you need to go back and you need to quickly do this. Make sure that you get 2/9 in there. Everybody good with that?
Yeah.
All right, next question. This is learning target number 3. So now we would be doing x and we'd be doing 22. Since that's an open dot, I know it's either going to be less than or greater than. And since I'm talking about solutions bigger, my inequality symbol is going to be trying to eat the x because we're talking about solutions greater than 22. Everybody got that?
Yeah.
X greater than 22. So there you go on that one. Pretty easy, I think. Okay, so this is going to be learning target number 4 again. We draw my line. We ask ourselves what is happening to the variable. That variable is being divided by 3, so I'm going to multiply by 3 to both sides. That is going to be x being greater than or equal to 15. Okay, x is greater than or equal to 15. Now, once again, here we go. This is my coordinate right here. All I'm going to do is I'm going to take my x. I'm going to plug it in. Right? Guys? I'm going to plug it in. And I know that if I plug that in, whatever I get out of that, that's the coordinate. I've already said if I want to go to the coordinate 1 something for this particular line, I got to do this math right here. I got to plug this in. So when I do that, I do 2 times 1 is 2, plus 4 would be 6. So would 1/5 be on this line? No. Would 1/6 be on the line?
Yeah.
Yes, because that's the y that I got out. That's the dependent variable that I got, the y. Okay, let's go on, just because I want to get as many in as possible. So now I'm going to draw my line, right? I'm obviously going to subtract 1/4. What work would I need to see here, though? What's the little bit of difference that maybe from when they're whole numbers? Lexi?
Having a common denominator.
Yeah, so what would be a good common denominator to use here?
4.
Perfect. So I'm going to use 4 there, which, just remember, you got to do whatever you did to the bottom to the top. Guys, do you need to show me this work on the test?
Yeah.
Yes, I'm going to get 5/4. I'm going to learn that x equals 5/4. Or 1 1/4. But remember, we don't use mixed numbers in algebra. Should I take this and plug it in real quick?
Yes.
Absolutely. When I do 5 over 4 minus 1/4, I get what? Wait, no.
What? 1 and 1. It's supposed to be.
I'm sorry, plus. Jeez, plus. That's going to be 6/4, which then I'd have to simplify to get 3 over 2. Everybody good with that?
Yeah.
Okay, good. Okay? Assure you guys, this is on the video. Listen, hey, I'm saying this on the video. This will be on the test tomorrow. A question just like this one. We had one just like this on the formative. I think it dealt with somebody mowing yards or something, if I remember right. Or babysitting. Okay, now look, Quentin earns $12 per hour. Okay, last week he made more than $24. So right away, is this going to be an equation? No, it's going to be a what? It's going to be an inequality because you used one of those inequality words. So I know that he did 12 times the number of hours he worked, and I know that that had to be more than the $24 that we know he made more than, right? Now, if I'm able to solve this, I'm going to learn that, obviously, I'm going to divide 12. That's going to tell me that x, the amount of hours that he worked, had to be greater than 2, right? So some people say, well, he could have worked 3 hours. Well, that's not necessarily true. Couldn't he have worked 2 hours and 1 minute? Sure he could have. Okay, just understand that. It's more than 2 hours. That's how much he worked. More than 2. That's what I'm looking for there. Okay? All right. Let's go.
Can you go back to
The answer was x greater than 2. Okay?
Can you,
Shh, guys. This one? Go ahead. So obviously this is writing the equations from the word problems. Okay, these can be kind of tricky, but for the most part, you guys did a nice job. Now, Ava spent $10 of the money she earned selling her hair. She has $8 left. Let X equal the amount of money that Ava earned selling her hair. So we're starting with X because that's how much she started with. Then if you spent $10, what operation were we talking about? You're subtracting 10, and then what did that equal? 8. A lot of people are doing this. A lot of people are trying to do 10 plus 8 equals X. Guys, that's not an equation. That's just an expression. In equation, you have to have something happening to your variable. That's kind of the way I like to say it, because something has to be happening here, and then we're getting a result. Everybody understand that? So you always have to have something happening to your variable. Now, when you solve this, we've done enough solving today, I'd say. We know that that's going to end up being X equaling $18. That's how much money she must have made for selling her hair. Okay? Shh, guy. Okay? So here we go. There are a maximum of 8 cool kids in this class. So I know we got 8X and we got 8. Now, with the word maximum, would that be including the 8? Could there be exactly 8 cool kids? Yeah. Yes, there could. So now you need to determine whether or not a maximum would be 8 or less or 8 or more. Unisa, what do you think? 8 or less. So then that would be less than or equal to 8. So this is obviously learning target number 1. Pretty easy question here, I think. Most of you could do this mentally. But again, it's not about really finding that X equals 3. It's about the process of it. So here we go again. So we know that we ask ourselves what is happening to the variable. Well, we're going to undo that. So now we're going to divide by 2. And that's how we learn that X is going to equal 3. Am I done?
No.
No. You always need to take it and just plug it in. It takes an extra 5 seconds, maybe 30 seconds if it's a fraction. Just do it. It'll save you guys. Trust me. Okay? Because there are just so many little mistakes you can make. Okay? 2 times 3 would be 6, though, so we know that is correct. Okay? Okay. Please listen. Okay? Now, I'll say this one more time just so the video gets it. You have to prove this. If you're just going to go through here and say, yep, that's false, it will be incorrect. I won't count it right. I don't care whether you got it right or not. You have to show me why you thought it was false. So basically, I'm not rewarding guessing. If you guess, it's going to be wrong automatically because you're not telling me you know it anyway. So you have to prove it. Okay? So there's 2 ways to prove it. 2 methods. We talked about these on the formative also. Okay, there's 2 ways. The first way, and I think probably the best way, is just to go ahead and solve this equation. You guys all know how to solve equations. I feel like you all think... I feel like all of you think, or all of you feel like solving equations is pretty easy. Would you guys agree with that? Yeah. You guys do a nice job with that. And there we go. If I learn that when I plug in 24 for X, or I'm sorry, when I solve for X and I get 144 for here, obviously that's not 144. Right now I just proved that it was false. Okay, that's one method of doing it, which is a fine method. That's fine. The other method that you could do is you can just take this and plug it in, right? Mm-hmm. So then you're basically saying, okay, is 6 divided by 4 24? Are you saying that? No, it's not. It's actually points, or it's 1.5. It's not. Yeah, 1.5. Yes. Yeah. Okay. Everybody good with that? All right. So it's false. It is false. Okay. This is going to be learning target number 3. Okay. So if we're going to say a number X is less than 14, okay, so we know we're talking about X, we know we're talking about 14. Now you just got to understand what a less than symbol is. Less thans look like an L, right? Yeah. Looks like an L. Okay, if you didn't have to do this, but if you did graph it, I'll just show you, just so that we're practicing this at the same time. This would be 0, 14 would be there, negative 14 would be there. Okay, and that would be an open or a closed dot, guys? Open, and we're talking about this number X being less than, so that would be to the left, right? Okay, let's go on. So, this is what we worked on. Please be listening when I start to go over one, please, because this will be on the test tomorrow. Now, well, I'll say that in a minute. I'll just show you this for now. Remember, this is a line. Do you guys understand why that's a line? No, you don't. Do you care why it's a line? Not yet. That has really nothing to do with what we're really trying to accomplish here. It has nothing... That is not the point. What you do know is that if I draw a line, is there a lot of little coordinates that line it has? Like there's a coordinate there, coordinate there, coordinate there. That's really all the point is we want to be able to determine whether or not a coordinate falls on a specific line. Well, here's how you take care of that. You look at it and you say, okay, this right here, I'm just going to take that, I'm going to plug it in. This is what you'd have to show me, by the way, the work-wise. You're going to plug in that x, because that's an x value. And you know that when you plug in 1 there, if it gives you 5, then yes, the answer would be yes. So you got to do some work here. So I like to just rewrite it like this. I like to say, okay, that's going to be 2 times 1 plus 4. 2 times 1 is?
3.
Guys.
1.
2 times 1 is 2 times 1 is 2. 2 plus 4 would equal 6. So as I look at this right now, I'm looking going, okay, for that line right there, I know that there's a coordinate that would have that, or the coordinate would be 1, 6 that would fall on that line, right? Yeah. So therefore, does that fall on the line? No. No, it does not, because it didn't spit out the same y that it's supposed to. If it would have given me 5 here, then yes, it would have, but it did not. Now, I'll tell you this real quick while I have you listening about this. The way it's going to look on the summative tomorrow is it's going to look like, I think I erased it, but I'm basically going to give you something like this. Please listen, guys. I'm giving you what the test is going to look like. And I'm going to give you that, and then I'm going to say, I'm going to give you a bunch of points. And I'm going to say, here. Now, I'm just making them up. I don't know whether these will actually fall on that line or not. We can check. But, yeah. But you're going to have to go through and figure out which ones are not on the line. So that means every time you plug in this, like here, if I plug in 4 there, that would be 2 times 8. What is 8 minus 4? So that means the point 4 is on the line, right, guys? Yeah. So is 4 2 on the line? No. So that would be 1. It would be circled because you're trying to determine which ones are not on the line. Everybody got that? Yeah. Okay. Alrighty. Let's go on. Yeah. Okay. So here we have an equation. Now this is probably the hardest variety of the one-step equations. Now they're going to get more complicated as you go through school, but for what we're trying to accomplish here, Manny, pay attention. When you start getting fractions with unlike denominators, that's probably what maybe is the most tricky. So we know, you guys all knew you were supposed to subtract 7/4. That's all cool. What work would I need to see, though? Sammy? So what would be a good common to use, Sammy? 4 would be perfect. And then whatever I do to the bottom, I must do to the top. So that's going to end up becoming 10/7. So I know that over here I'm left with just x equaling something, right? Then I just got to do whatever my difference is. That's 3/4. 3/4 is my answer. Am I done with this problem, though?
No, you have to.
No, you got to take it and quickly plug it in. So I'm going to go off to the side. I'm going to do 3/4 plus 7/4. This better equal 5/2, or I've done something wrong. Now initially it might not look like 5/2, right? But you know you must simplify that, and you would get 5/2, which is what it was supposed to be. Everybody got that? Yeah. Okay, good. Okay, so then we start with x. We start with 3. We see that it's an open dot, so it's either less than or greater than. Since we're talking about solutions less than, we do that one. Now, we always check a solution just to make sure. Would it try to eat the 2 if that was a 2, or would it try to eat the 3?
It would try to eat the 3.
So obviously we got it right then by using that little check method. Okay? None. Okay, you could have done this in 2 ways. Okay, the first way, you could solve this. Now, you don't know solving 2 steps, which means 2 things happening to the variable. That's not going to be on the test. But you know how to do it, so you could. Remember, we don't do PEMDAS, we do, you guys remember? Or PEMDAS backwards. So basically we're undoing, we're undoing addition or subtraction first. So I'm going to subtract 4. That's going to leave me with 3x equaling 6, and then solve, divide 3. That's going to give me that x equals 2. That's fine, and then when we find out it's true. Now, you're not responsible to know how to do this on this test. You are on review sheets, not on this test. The other way, or the way I'd want you to do this question, would be to simply take this and plug it in. So I'd be doing 3 times 2 plus 4. That's going to be 6 plus 4, and then is that 10, guys? Yeah. So I know it's true. Okay? So true is the answer there.
Yeah, 2 more. Two more. I just need 1 more. 2 more.
All right, guys. Now, this was the most missed question on the entire test right here. That's why I got a star on it. Okay? So, when I'm doing this question right here, Quentin earns $12 an hour. Last week, he made more than $24. If it would have said he would have made $24, you guys would have all known he would have worked 2 hours, right? Because 2 times 12 is 24. But it says he worked more than, so you got to be a little bit creative here. You know that 12 is how much he makes per hour. X is representing the amount of hours he worked. And we know that it has to be more than or greater than 24. Well, now if you solve this, you would divide 12, divide 12. That would tell you that this is going to be X greater than 2. He had to work more than 2 hours, which means he could have worked 2 hours and 1 minute, but he had to work over 2 hours. Everybody got that? Okay, as long as you got it. I'm recording, so quiet. Okay, so this is learning target 4. Okay, I did several of these throughout the video, but this is just solving an inequality. Very similar to solving an equation, only now it's just got that symbol instead of an equal sign. So we still ask the question, what? What is happening to the variable? And then once we figure out what is happening to the variable, then we're gonna undo what is happening to the variable. So we are going to add 8 because we were taking 8 away. So we're going to add 8 to both the left and the right side. We're going to learn that my solutions must have been greater than or equal to 40. So you can mark that spot if you have it available on your bingo board. Now, just to clarify, you didn't have to do this, but I'll just for an extra little practice, make sure you guys are all good. If I were graphing this, I would be doing 0, 40, and negative 40. Would I be using an open or a closed dot? It would be a closed dot, and my solutions would be greater than 40. Remember, it's trying to eat the x, so that means my solution's here. What's the last step I should do just to be certain, though?
Plug it in.
Just plug in maybe 45. Is that a true statement, guys?
Yeah.
Yes, it is. Okay, so if I have less than 5, please be with me. I have less than 5 friends. Okay, so we're going to let the variable x just represent how many friends I really do have, because we don't know how many friends exactly I have. But I know I have less than 5 friends, so it's going to be x and 5. Now, when you see less than, is that going to include 5? Can I have 5 friends exactly?
No.
No, because I have less than that. If I have less than that or more than that, I can't have that amount, right? Okay, so we know right away it's either going to be a less than or greater than. Once again, I've said it 100 times throughout this chapter. Guys, if you have trouble remembering which is which, just remember the word less than starts with an L, and that kind of looks like an L. It's a squished down version of an L. Okay, so it would be x less than 5. If we were graphing this, it would look like this. We'd put 0, 5, negative 5. This would be an open dot. Now, the only thing that would be a little different here is realistically, you really can't have negative friends. Okay, so really it'd only go to there, but you guys get the picture. It'd be x less than 5.